We're going to take a quick look at scientific notation. So the first question is, what is scientific notation? Scientific notation is a method used to express very large numbers or very small numbers shorthand. So our first example is 1 drop of water. So in a single drop of water, there are this many water molecules, our little water molecules of H2O. So that's a really big number, and it takes a lot of time to write down all of these zeros. And so scientific notation makes it easier to represent this number without having to write all the zeros. So writing it in scientific notation, I get 1.67 times 10 to the 21st power. So 1 drop of water has 1.67 times 10 to the 21 molecules of H2O. So that number was a lot easier to write than this really long number, okay? And we're going to get to the decimal being here in just a moment. All right, so what about very small? So an example of something that's very small is something that's a nanometer in size. So when we think about a meter stick, there's 100 centimeters in a meter. And so a nanometer is actually 0.0000000001 meters. And so it's really, really small. So some things that are nanometer in size are a cold virus or a water molecule. So representing that nanometer in meters, a cold virus would be 8 times 10 to the negative 8 meters. And then a water molecule would be 1 times 10 to the negative 10 meters. So it's just an easier way to represent the size of these very, very small things without writing all of those zeros. So how does scientific notation work? Well, you take the really big or really small number and write the number as a product of two factors in the form of a times x to the n. So here is one factor, a, and here's the other factor, 10 to the n. So here's my multiplication that shows that I'm writing as a product. So our n is going to be an integer, which means it can either be a positive number or a negative number. And our value for a has to be greater or equal to 1. So it can be 1, but it has to be 1 or greater than 1, but it has to be less than 10. So that means that our value for a can be 9, anywhere down to 1, so any of those decimal places in between. So going back up here to our drop of water, we had 1.67. So A here is definitely greater than or equal to 1, but it's less than 10. Okay, so the value for n is determined by the number of places you have to move the decimal in order to get that a, that value that we're going to plug here for a, to be greater than or equal to 1, but less than 10. So we have to move that decimal a certain number of places so that we get that, that number, that decimal. So let's look at the first example. We have this really big number, and I didn't put my commas in, okay? But I have a lot of zeros. And so I want to put this in scientific notation. Well, right now my decimal is here. Okay, and I want my decimal to be between the 2 and the 3. By getting the decimal between the 2 and the 3, then my value for a is going to be greater than or equal to 1, but it's going to be less than 10 because it's going to be 2.34, and that value is less than 10. So I need to count how many places until I reach right here. Okay, so right now the decimal's here, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it took 14 places to get my decimal to the 2 and the 3. So that means my 10 is going to be raised to the power of 14. So this problem, or this number, can be re-represented in scientific notation by 2.34 times 10 to the 14th. Now notice that I do have a positive exponent. So let's look at one where we're going to have a negative exponent. So in the positive exponent, notice we had this really big number and we had to move the decimal left. And when we moved it left, we got an exponent that was positive. All right, so let's look at a really small number. So that is a really, really small number, okay? So I want to represent this number in scientific notation. So I want it to be a times 10 to the n, where my a is greater than or equal to 1, but it's less than 10, which means if I put my decimal place here before the 3, then I'm going to have a number that's smaller than 1. If I put it here on the other side of 5, then I'm going to have 35, and that's greater than 10. So I want my decimal place here in between the 3 and the 5. So first I need to determine, so I know that I want it to be 3.5 times 10, and now we need to determine what we're going to raise this power to. So I need to count how many decimal places it took to get to 3.5. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it took 19 decimal moves. Now, this is a really, really small number, okay? And so now our exponent is going to be negative. And I've already forgot what that number was. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 10 to the negative 19, okay? And as we learned last week about simplifying, a base that is raised to a negative exponent, if you understood that, then that should help you understand why it's negative. Notice how we have a point and we have this really small number, okay? Well, when I go to simplify this particular a to the negative x, I simplify it by putting it 1, right, 1 over a to the x, okay? And so that's how I simplify a negative exponent. And so when we think about this 10 to the negative 19, that should make sense because then you're going to have a 1 in the numerator, and you are going to have 10 to the 19 in the denominator. Now that was really horrible. Let me change this 10 to the 19 in the denominator. Well, when you go to do this math, then basically you're going to say, okay, well, what is, let's see, and I think I've done 19 here, I'm not sure, and then divided by, or, that goes on the outside, and I can't do a symbol. I'm sorry, I can't do a symbol. I'm going to have to stop. But basically, you're saying, what is 1 divided by 10 to the 19th? And obviously, 1 divided by 10 to the 19th is going to be a very small number. Think about it. 1 divided by 2 is 0.5. So 1 divided by 10 to the 19 is going to be this incredibly small number. Well, here's your incredibly small number. So the main point is that when you have a positive exponent, that means your decimal had been moved to the left. When you have a negative exponent, that means your decimal had been moved to the right.